Our next section is going to go through some applications and some properties about our quadratic functions. So the very first thing we're going to talk about is this parabola has a really nice shape. So there's actually always going to be a maximum or a minimum value. It just depends on which way the function opens. When we talk about finding a max or min value, we're going to be concerned with finding the y value. So think about our two different cases that we have. We have a parabola, maybe it opens downward, and we know we can find that vertex hk. So that's kind of our starting point. If the parabola opens downward, then the vertex is going to be the absolute maximum y value here. So in this case, y equals k is the max value. There is no other y value larger than that. In the case where our parabola opens upward, maybe our vertex is over here, hk. So our vertex is right down here, and then we have that parabola shape. In this instance, y equals k is our minimum value. Okay. So depending on the question, if you're asked to find the max or min value, you're really just finding the y coordinate of the vertex. But if you're asked to find where the max or min occurs, that's the x coordinate for it. So let's take a look at an example. We want to determine if the function has a max or min value, and then we actually want to find the max or min value. And so thinking of this parabola, the value out front is positive. So this is a parabola that opens upward. So because of that, there's going to be a minimum value. Okay. And that minimum value is exactly the y coordinate of the vertex. But in order to find the y coordinate of the vertex, we need to find the x coordinate first. So if you remember, to find the x coordinate, that's our value h, it's negative b divided by 2a. And in this case, our value of b is negative 40. So this is negative 40 over 2a, and a is equal to 10. So this ends up being positive 40 over 20, or just 2. Okay. So the vertex here occurs at 2, and then our y coordinate, which is the minimum value, we just go ahead and plug 2 into the function. So this would be 10 times 2 squared minus 40 times 2 plus 43. Which would be 10 times 4 minus 80 plus 43, which is 40 minus 80 plus 43, which ends up being 3. Okay. So our minimum value then is 3. That is the y coordinate of the vertex. So now let's just try some applications, and in all honesty, for a lot of these problems, there isn't one set approach, but you're going to be finding a quadratic, and you're going to either have to solve some kind of quadratic equation, or if you're trying to maximize or minimize something, you're going to be looking for the vertex. So for this first problem, we're told a farmer has 800 feet of fence to enclose a rectangular area. We want to figure out what dimensions for the rectangle result in the maximum area enclosed by the fence. So let's draw a little bit of a picture as to what's going on. We're working with a rectangle. Let's see if I can make this form a rectangle. Close enough, that's a square, but it's going to end up being a square. So I don't know the side length, so I'm going to call this side x, and I have no idea what this side length is, but it's a rectangle, so this side is equal to y. The problem is I want to maximize the area, which is our length times width. So it's x times y. The problem is this is technically a multivariable function. That's something you're not going to learn how to deal with until you hit Calc 3. So I've got to be able to turn this into a parabola of some sort, because if I want to maximize it, I find the vertex. And this is where we're going to use this other piece of information. We have 800 feet of fencing. So this really means our perimeter is equal to 800. So based on that, if I go ahead and add up all the sides, x plus y needs to equal 800. Or that's the same thing as saying 2x plus 2y equals 800. Okay. So what I can actually do is I can use this restriction to go ahead and solve for one of these two variables. So if I can replace y by something dealing with x, I've got a single variable function. So going through and solving this, we go ahead and subtract 2x from both sides. And this is 2y equals negative 2x plus 800. And then we go ahead and we divide everything by 2. And so our y is equal to negative x plus 400. Okay. So the y that's in our area formula should also be this exact same y. So I can go ahead and replace that in this equation to get x times negative x plus 400, which is negative x squared plus 400x. Okay. And this now gives us our area as a quadratic. And our goal is to maximize the area, so I want to find the maximum of this parabola. And it's got a negative value of a, so it's a parabola that opens upward. So I'm trying to find the max area. I want the y coordinate of the vertex to find the maximum area. So our x coordinate of the vertex is h. It's equal to negative b, so negative 400 over 2a, which is negative 400 over negative 2, leaving us with 200. So our x should equal 200 feet to give us the maximum area. Now specifically, what we're looking for are the dimensions of the rectangle for the maximum area. So we just found out the x needs to equal 200. And so our other value, we can go ahead and we can use this equation here. So the other side length, y, is equal to negative x plus 400. The other side length should also be 200 feet. So the dimensions that result in the maximum area are 200 feet by 200 feet, meaning a square is going to give us the maximum area. If you wanted the maximum area itself, you could just multiply these two, or again, you can find the y coordinate of this by plugging in 200, and that would also give you the maximum area. Okay, so just pay attention to what specific property you're looking for. Are you looking for dimensions? Are you looking for the actual maximum area? It's all going to be problem specific as to which piece you need to give. All right, so let's try one more. This one's a little bit more difficult just because of the specific thing that you need and how things are worded. So we're told a kite is flying on 369 feet of string. How high is it above the ground if its height is 279 more than the horizontal distance from the person flying it? So I definitely want to draw a little picture as to what's going on. Here's our guy with a kite. And we're told this is 369 feet of string. So the distance from the person to that kite is 369. Okay. And we know something about the horizontal and vertical distance. So we're going to go ahead and we're going to draw a triangle in here. Okay. I know that the height is 279 feet more, but the thing I'm looking for is how high is it above the ground? That doesn't say ground, but pretend it says ground. I am specifically looking for this side length here. So I'm going to label this as x because in the end, I want to find what is x equal to. If I don't do this, I'm going to have to remember I have to go back to do something else. Because the thing that's confusing with this one, we're told its height is 279 feet more than the horizontal distance. So what tends to happen just based on that, I would call this x and say this has to equal x plus 279 then, because the height is 279 more than the horizontal distance. The problem is then when I go to set up an equation involving this, I'm going to get x equals something. But this is the side length that I'm looking for, which is why I want to avoid putting it this way. Again, you'll get the same answer, but you'd have to remember that there's an extra step at the end. So the easier way we can interpret this other piece of information is if our height is equal to x, it is 279 feet more than the horizontal distance. So say if this side length is 500, this side length would be 500 minus 279, okay? So what I can do, since it's this unknown expression, I take the vertical distance and I have to subtract 279 to get the horizontal distance, okay? And this just makes, again, my life a little bit easier because we have x as the vertical distance, and that's exactly what we want to find, okay? And now from here, I've got to set up an equation involving x, and I've got a right triangle in here, so my Pythagorean theorem is going to be the best thing to use. So I take one side squared, I add to it the other side squared, and that equals my hypotenuse squared. So unfortunately, we're going to get some real big numbers. This is x squared. If you go ahead and FOIL this out, I'm going to trust you can do that. It would be x squared minus 558x. And then you'd have to do 279 squared, which is 77,841. And then on the right-hand side, we go ahead and do 369 squared. That is 136,161. So in setting up this Pythagorean theorem, we end up with a quadratic equation that we need to solve. So going through our process, we got to get 0 on one side. So much easier to just move this constant over by subtracting it. The other thing we can do is we have an x and an x, so we can make that x squared. So we have x squared minus 558x, and then if you subtract this 2, it'll be negative 58,320, and that has to equal 0. Okay. So you can make your life a little bit easier. You could divide by 2 if you wanted to not have to deal with such big numbers, because I forgot to put the 2 there in front of the x. You could also try to factor this, but with such a large number here, I would just totally avoid trying to factor it all. So let's go ahead and use our quadratic formula. So I'm going to move this off to the side. Our value of A is 2. Our value of B is negative 558. And our value of C is negative 58,320. So to get our solutions, we do negative B, so that turns to positive 558, plus or minus, I'm going to have to take a square root, but I'm going to write all this out first. B squared minus 4AC, and that's underneath the radical, all over 2A. Okay. So at this point, I trust that you're going to be able to plug this into a calculator. If you do 558 squared minus all of that stuff, what you're going to be left with under the radical is 777,924. And then this is divided by 4. And that happens to work out. It is a perfect square. So this is 558 plus or minus 882 over 4. So we technically get two solutions, 558 plus 882 over 4. And then 558 minus 882 over 4. Okay. So if you go ahead and plug that into your calculator, the first one's going to give you 360. And then the second one actually gives you negative 81. So this one doesn't make sense for our problem because x is representing a length I can't have a negative length. So the value of x, which is how high it is above the ground, is equal to 360. That is the height above the ground. So again, if you had relabeled this slightly, just go back to your picture. What exactly side, or which side did you exactly find? And then figure out the height from there. So you might have just a little bit of extra work to do. But all of these problems, you're gonna see there's other applications when you're dealing with like projectiles. If you kick a ball, it's gonna have a parabola shape. It goes up and comes back down. And the maximum height of the ball is gonna occur at the vertex. And the time it takes to get there is going to be the x-coordinate of the vertex. So there's a lot of applications to this shape that you're going to see pop up. So this is a really cool function for us.